Today we're going to learn about time value of money concepts as we learn about how to compute for present values, future values, annuities, okay, amortization, and we're going to make use of Excel. Since this is fully online, we will have no problem with that. Okay, so let's first take a look at the concept of computing for the present and the future values of a single cash flow. Okay, so here, this is a single cash flow. What do you mean by a single cash flow? By a single cash flow, we mean, let me use this. So we have our, for example, this is time 0, this is time 1. So when we look for the present value, for example, we have one cash flow. It might be on year 1, year 2, year N, okay, for that matter, N. So you have this single cash flow, say 100,000, and you'd like to get the present value of that. How much is the equivalent of 100,000 after N years? How much is it equivalent now? Okay, that's what we mean by getting the present value of a single cash flow. Okay, this is just one cash flow. Okay, the reverse is that we're given the cash flow now, and we would like to know how much is that N years from now. So that's what we call the future value. How much will be a cash flow now or at some point in time? Okay, how much will it be in the future? So that's what we mean by getting the present or the future values of a single cash flow. Okay. Am I recording? Yes, okay. Okay, where do I stop recording? There's no stop recording. Okay, so to compute for the future value, we use this formula. The future value is equal to the present value times 1 plus r raised to the t. Okay, this is different from what we have been doing before, where to compute for the maturity value, remember for the simple interest, we use the formula maturity value. Okay, maturity value is equal to the principal plus the interest, right? Which is equal to principal plus the P principal times rate times time. And this reduces to, if you recall from our discussions, principal times 1 plus RT. Okay, so this is the simple interest factor. On the other hand, to to compute for the maturity value or the future value, we have using a compounding, we have this present value times 1 plus r raised to the t. It's just like present value times 1 plus r raised to the t. Okay, so that's the difference between a simple interest and a compounded interest. The factor, the compounding factor, is very much different from the simple interest factor. The t, the number of period, is exponentiated here, while here it's just a linear function of r. Just multiply it with r. But this one here, we exponentiate it, we raise it to the power t. So the compound factor will always yield a higher value compared to the simple interest factor. Okay, so let's use Excel in order to compute these things. Okay, so as an example, we were given present value of 1 million. Okay, if we're going to put 1 million in an instrument that earns 12% per annum, okay, take note, the rate given is always assumed to be per annum, and we're going to let it stay there for 20 years. How much will be our how much will be the amount after 20 years? And we call that future value. So let's first use the formula. Okay, let's use the formula PV. Let's interchange this. So I'm going to use the formula. Our present value is 1 million. The number of years is 20, and then the rate is 12%. So this is equal to our present value is 1 million. And then we multiply this by the compound factor. The compound factor is 1 plus, following this formula, our rate is B11, okay? And then how do you raise in Excel, class? How do you raise to a particular exponent? Anyone? You should be raised to the 20th power. All right, thank you, Patricia. We use the caret symbol, right? So it depends on the machine that you're using, but it's usually at the top of the number 6. So in my laptop, it's at the top. So I use shift, okay, shift and then 6, and then the number of years there. Let's raise to the t. Okay, let me wait for you to use this formula. And once you're done, class, kindly please chat the answer that you get. Okay, let's see. So from Fiona, it's 9.6 million. How about the others, class? Okay, let's wait for your answers. Okay, Lisa, same. Thank you. Gerald, same. Let's see more hands, guys. Let's see more answers. Thank you, Nathan. Okay, I think all of you are the same. Martina, pareho din. Christine, the same. Gerald, yeah, good. Schuyler, thank you. Okay, same. All right, thank you so much, class. Okay, so it seems like everybody got the same answer. Did anyone get a different answer? Anyone getting the different answer? Okay, so none. Okay, so let me see. So it's 946,646,293. So we got the same answer. So how much is 1 million 20 years later if you put it in an investment that earns 12%? The answer is 9,46293. Now it would be different had we used a simple interest. So let's do that. If it's a simple interest, it will be the principal times 1 plus the rate is 12% times T. Right? Okay. Control Enter. This would have just given us 3,400. Okay, it would have just given us 3,400,000. Okay, so it's you can see the difference between a compounding factor and a simple interest factor, right? Worlds apart. Of course, if you invest, you would want that your money grows uh, with a compounded interest. You don't want your money grow just using the simple interest. Okay. Okay. In fact, we can let's try to plot. Okay. Let me now let's see. So we have a principal of let's try to see the difference between 1 million. This one using simple interest. This one using compound interest. So this is the principal. And our rate, let's peg it at 12%. Okay, the one a while ago. And then here for the year, let's see from 1, 2, 3, up to 20. Okay, what are we doing? We're going to compute for the future value or the maturity value using simple interest versus compound interest. Okay, so let's do this. Let's give this names. Okay, I'm going to give this a name. Okay, you recall this, class? Control Shift F3. Okay, so the names are in the right side, left column, I mean. Okay. Okay, let me pause for a while. Okay, this is P and this is rate. Okay, pause for a while and give you time to set up your model. What we're interested in is we would like to see the difference between a simple interest and a compound interest, assuming that the principal is 1 million and the rate is at 12%. Let's see the difference between using simple interest and compound interest. Okay, kindly please tell me if you have set this up. Okay, I will wait for you to set this up. Kindly chat yes if you have done so that we do this together. And you have given these names. This one, we called it P. This one, we called it rate. Okay, kindly chat, please, if you have done that. Or if, in case you have questions, please feel free to ask questions for me to repeat. Maybe I'm going too fast. Yes, Gerard.
So how did you slide it to go like 1, 2, 3, 4, 5, 6?
Okay. Okay. Thank you. Thank you. Okay. Good question. Because sometimes if you need to list numbers, say from 1 to 20, are you using Mac or Windows?
Windows.
Windows. Okay. So you can write first 1, and then 2, and then 3. Just establish the pattern, and then highlight this. Okay. And then highlight 1, 2, 3, and then hover through the 1, 2, 3, and then you'll see this crosshair at the lower right, ba? And then just drag it until you get to 20. There.
Thank you, Say.
Got it?
Yes, Say. Thanks.
Okay. Okay. My question dito si Patricia, for the compound interest, will we use the future value? Okay, since we're given the present value, this is the present value, then we will be computing for the future value. Okay, so we will see how much 1 million will be after 1 year, 2 years, down the line up to 20 years. By the way, Gerard had a good question. Let me teach you another way. Okay, so there's another way to do this. If you're doing a list, for example, 1 to 100. Okay, so you can do that 1, and then 2, and then 3, and then you can drag this down up to 100. But that can be also very difficult. Okay, see, it's quite difficult to drag it down up to 100. So let me delete that. What we can do is, so from here, okay, from here, okay, what we can do is under home, and then editing, you can you see this one, fill? You can use this fill. I I uh, I click that fill, and then there's a series here, series. Okay, so it asks me series in rows or columns. Okay, I want it in columns because I want it to go down. Okay, and then, okay, so wait, I have to start with, I have to put this. So let me start with 1. So you have to put 1 here, and then you go to the home tab, and then under the editing, okay, home, and then editing, you'll find this fill, and then do series. Okay, series in, if you make it rows, it will create a series going to the right. I want the series in columns. I want it to go down, and then we can click here trend. Okay, or no need to use trend. Step value means by what increment do you want the series to be in. So step value, I want it to be by ones, no? Just like adding one, you keep on adding 1 until, let's see, step value at, let's see, 1 million. So I'm saying that Excel creates a series in columns, okay, starting with 1, starting here with the number I wrote, 1. Step value is 1, so it means it will keep on adding 1 until it reaches, this is, I think this is only 100,000. I'll make it 1 million just to dramatize the example. Okay, all right, see, and then there, guys, it gave us the series until 1 million. Okay, so very easy to list. Imagine if you're going to use the method that I taught Gerald a while ago, which is type 1, 2, 3, and then click down or drag down 1 million. That will be really very, very difficult. Okay? Imagine just dragging your mouse until 1 million. Okay, so let me delete that. Control C. Okay, was that clear, class? Okay, sige. My question is to Patricia. we'll go there, Patricia, no? In a while. So let me just make sure that you got the year 1 to 20. So let me illustrate that again. Home, be sure you have your 1 here. Okay, and then home, and then here fill, okay, series, and then in columns, and then I want the stop value to be 20. There. Okay, there you go. So that's 1 up to 20. All right, kindly chat, please, if you were able to get this. Filling in a series. No, any clarification about that? Okay, kindly chat, please, if you were able to get that. Chat na lang kung yes or no. Feedback from the class, please. If you were able to get that, yung shortcut to generate a series of numbers in columns. Okay, good. That's very helpful. Plus, actually, imagine just for the sake of discussion, if you were to generate a series of numbers from 1 up to 1 million with increments of 1. And the good thing about this is that you can use increments of 5. Okay, you can start with 0 and then increments by 5, 5, 10, 15, 20, up to any number you want. It's very easy to generate a series of numbers. All right, so let's now compute for the simple interest and the compound interest. So we'll create one formula here, and then copy it down. Okay, so for the simple interest, what's our formula? Remember, the maturity value is equal to P, right? Times 1 plus RT, right? So for this one, it's P times 1 plus R, and then it's raised to the T. There, okay? So that's the difference between these two formulas. Okay, and you can see here the marked difference between a simple interest and a compound interest. Okay, so let's do this. So this is equal to, our P is just this one, right? So if I click this, it will already be P. So that will be fixed. This is already fixed and it will not change because the principal will always be this amount, right? And then multiply that by 1 plus our R is this one. So that's the rate, right? And then we're going to multiply it by T. Our T is this one. Okay, now, okay, so let me first close this and let's see what happens. Enter. And let's format this. Just 1 decimal place. Okay. All right, maybe 2 decimal places. Okay. So after 1 year, our 1 million is 1,120,000. But can I copy this to the right? If I copy this to the right, what happens? I'm getting an error term. Why? Why? Because if I flush the formula, so what happened was, so that's P. And by the way, we cannot copy to the right because the formula is 1 plus R raised to the T. Okay, so I'm going to change the formula. It will be 1 plus the rate and then raised to the time here. There. Okay, so I think somebody asked a question a while ago. Let me check the chat. Okay, I think it was Patricia who asked, how do we lock a certain cell so that we can only have to change the time? Okay, now when you give a name to a cell, okay, that's already locked. So that's the advantage of giving names to cells. This is already locked. And I'm going to illustrate this using another way. Okay, so Patricia, did that answer your question? Okay, good. All right. Oops. So for this first year, they're the same because this is R times T. R times T is 1, so this becomes 1 plus R, right? This one also 1 plus R. T is 1, therefore this also becomes 1 plus R. So for the first year, they will be the same. Okay. Now, can we copy this formula down? If I highlight this 2, and then notice that our formula is dependent on E3, right? This is E3. There, E3 is here, the year. Okay, so actually I can highlight this and then just double click this. If I double click this, okay, it automatically computes everything. There. Okay, we can even, in fact, we can even dramatize the example by, so let me click down and then make it up to, just up to 50 years. So I copied it up to 50 years. Okay. And then what I'm going to do, let me illustrate this first, guys, and then let's go back and let's do this together again. I'll highlight this 2, Control Shift down arrow, insert, and then I'm going to insert a scatter plot. Okay, maybe this one, let's see. Okay, so this is the wrong graph. Okay, because I did not include the year, I should have included the year. Okay, my mistake. Control Shift down arrow. I'll illustrate first, class, and then I'm going to redo the process. Okay, take a look at this. So you can see here the difference between a compounded interest and a simple interest. You see the marked difference. This is the simple interest. It's just a linear. It's a linear curve, while this one is what we call an exponential curve. So the longer the number of years, you can see here the greater is the difference between a compounding interest and a simple interest. Okay, so let me delete this. Okay, let me redo this. Okay. I made it up to 50 years to dramatize the difference between simple interest and compound interest. So let me redo the formula so that everyone can follow along. So for the simple interest, the formula is whatever the face value is of the principal times 1 plus R times T. Okay, now conveniently what we did was to give a name to your P and your R also. We gave it names. Okay, and when we give names to cells, this will become automatically locked when we copy it down. Okay, so we have P, that's a principal. You notice that it's using P, and then times 1 plus your rate is this one, right? And we gave it a name. And then we multiply this by the time, times the time here. Okay, so that will be our formula. Then control enter, we have 1120. Okay, pause for a while, guys. Kindly please tell me if you were able to get this. For simple interest, it's 1120. Please chat if you were able to get that. Okay, thank you. Let's wait for the others. Only 5 have responded so far out of the 20 plus. As I said, class, in this subject, in this class, we're going to learn how to enhance our skills in Excel. Excel is a very powerful software, very powerful tool. There are many things that you can do with Excel. In particular, for example, for our lesson, time value of money, the computation really becomes very easy. That's why it's important for us to reinforce our skills in Excel. Okay, waiting for some more. I hope that everybody is following along. I hope that everybody is also keying in their answers in Excel. I'll stop once in a while, class, to make sure that you're able to follow, because of course there's a difference between you watching me and you doing your keyboard, unless you're using 2 laptops. Just have 12 responses. I'm waiting for 9 more. I hope everybody is following along. Okay, thank you. Good. A few more. Make sure that you were able to get the maturity value or the future value using simple interest. Okay, so that's good. Almost all of you were able to follow along. Good. Okay, thank you. Let me check. Maybe there are questions here. Okay, none. Okay, good. All right. So let's now compute for the compound for the, okay. This is using simple interest. So we're looking at the maturity value. This is using compound interest. So both of these are the maturity values or the future values. So this one will be equal to P. P also multiplied by 1 plus the rate, okay? And then caret, okay? Caret the year, this one. Okay, let me pause for a while for the others who are following along. And then we expect to get the same answer. Why? Because if here is 1, if we substitute 1 here, this becomes 1 plus r. Okay, and this one also 1 plus r raised to the 1. So 1 plus r raised to the 1 is the same as 1 plus r. So they will have the same factors. Okay, so if I enter that, we have the same value for year 1. Okay, let me pause for a while once again, and then request your chat if you were able to get the answer 112000 for the compound interest. Okay, good. Good, thank you. Okay, let's give a few more seconds to our classmates who haven't finished keying in the compounded interest. Okay, a few more seconds. I hope the others are also following along, unless you have questions. Okay, thank you. Okay, so now we can actually copy this. So there are several ways to copy this. We can copy this because the principal, if I, for example, if I copy this down, you notice the formula, it's still the principal times 1 plus the rate. Okay, and then since I copy down, it will go back down to the next year. So that's one advantage of giving names to cells, especially those to the absolute values. Okay, because it will fix itself. Okay, notice P times 1 plus the rate, it fixed itself. When I copy the formula down, it did not change position. Okay, so I can highlight both, and then if I highlight both and go to the down, the lower right corner, you'll see this cross here. This one, the one without any raise, cross lang yan, guys. Since the years are already specified, make the years up to 50 plus. So just to dramatize the point. Okay, so up to 50 years. And then I'll just highlight this both so that it will copy down the formula. And then just double click this. Okay, wait, let me remove this first. There. Okay, so you can now see the as we go longer, okay, you notice that the difference becomes greater. On the 50th year, your money would have grown to be 289 million. Okay, if the compounding was, if the interest was compounded annually, as compared to just 7 million for simple interest. So there's a big difference. So if I'm going to plot this, highlight year simple interest and compound interest, control shift down arrow. If I highlight everything, okay, and then okay, insert, and then here in the charts, let me use the scatter plot. Okay, let me use this one without the dots. Okay, so this one there. Okay, so you can see here the difference between a compounded interest there and a simple interest. Okay, let me pause for a while. Kindly chat, please, if you were able to plot, and you can see here visually. There's really a big difference if the interest is just a simple interest vis-a-vis a compounded interest. Okay. I would request a chat from you if you were able to generate this plot. Otherwise, if you have questions, please feel free to ask them. Okay, waiting for your feedback, class, if you were able to plot it. So let's wait for the others to give their feedback. Okay. See? Okay. So may... Okay. Fiona, saan yung ano? Saan ka na, na stall? Hello?
Sir, nawala po ako sa chart po.
Sige, sige. Okay. Thank you. Thank you for that question. Guys, please, thank you, Fiona, for asking that question. So let me just, for the benefit of those who got lost, dun sa pag-chart, first you have to highlight, no? Si year. Fiona, tanong ko lang, were you able to already, do you have these figures already, yung up to year 50?
Yes po, sir.
Okay, good. Okay. So once you have that, you have to highlight year. The first column will be your x-axis. So that's how our Excel is defaulted. You have to highlight year and the two other columns, the simple interest and the compound interest. And then here I'm using Control Shift down arrow to automatically, if I press Control Shift down arrow, it will automatically highlight all the cells. Okay, shortcut, no, keyboard shortcut. Control Shift and down arrow. Okay, so once you have highlighted it, or you can just highlight everything. Okay, oops, no, mali, sorry, makopy ko, no. So just highlight everything, okay, and then we go to insert. Insert here, insert, and then under insert you have the charts. Sa ribbons natin, andito si charts, and then you click this one. You can see here the scatter plot, just the dots. So we can choose the, I don't know, maybe you have a different interface, but you go to the chatter plot, the scatter plot, and then we just choose this one. Okay, the one without dots. You can choose this one, but it's not good looking. But I just choose this one, all right, and then click it. There you have it. Okay. Then we can just expand, just increase this, the size. All right. So were you able to get it?
Yes po, sir. Thank you po.
Okay, thank you. Thank you for those questions, guys. Please keep them coming. And I appreciate those of you who ask questions because you're keen to really follow along, and that's good. Okay. All right. So we can see that the red line, I hope it's clear to you, class, the big difference between a simple interest. This is just a line. Okay, it's just a straight line as compared to a compound interest, which is an exponential. This is called an exponential curve because the time is being exponentiated. It's raised to it's used as an exponent. For this one, the time is just used as a multiplicative factor. Okay, so let's go back to here to our lesson here. I just dramatized to you the big difference between compounding and simple interest. Okay, now we can use the formula, but Excel has a built-in function. Okay, so if I type is equal to, Excel has a built-in function called FB. Okay, so you can type FB there. And before you open, you type the parentheses. See here, returns the future value of an investment based on periodic constant payments and constant interest. Okay, so it gives us the future value or maturity value of an investment based on periodic or constant payments and a constant interest rate. Okay, so we have a periodic just once, no? Initial investment, and then we have a constant interest rate. Okay. All right. So you can now use the FB function of Excel. Okay. Pause muna ako, guys. Before we do that, let me first make a quick survey. Have you used the FD function before? Okay, paki-chat naman please. I would appreciate you chatting if you have used the FD. Thank you, Patricia. How about the others? Okay, good. Good, salamat. Good, good, good. How about the others, please? Yan, okay. Okay, happy for this, guys, because this is an opportunity for us to learn. No? So the FD function will allow us to compute for the future value given a single cash flow in the present. So we can now use the FD function. Okay, so there are certain parameters here, not everything that we're going to use. So first we have the rate. Okay, and we know that the rate is the per annum rate of 12%, comma, so I press comma there. N per stands for number of periods. Okay, number of periods, how many years? Okay. If it's monthly, how many months? But in this case, we're using annual data. So N per is this one, 20. And then comma. Now PMT stands for annuity. Okay, we're going to discuss annuity. Let's see, it depends on if we're able to reach that point. No, PMT is annuity, and an annuity is just a uniform stream of cash flow. So you have here, guys. Okay, I think I have what I gave you is an example. This is an annuity. Okay, so if you have cash flow here, say 10, 10, 10, 10, 10, 10, 10, uniform up to year 30, then that's what you call an annuity. So same amount for X number of years, that's called an annuity. Okay, now back to our formula here. Now this is not an annuity. This is just a single cash flow. Okay, right? We're investing 1 million now, and we would like to know how much will that be in 20 years time. So for PMT, you can either type 0 because this is not an annuity, 0 then comma, or you can just ignore that. Okay, so I'm not going to type anything. I'm just going to insert comma. So Excel will read this to be, this is empty, therefore Excel will read that to be 0. Okay, because we don't have an annuity, but rather we have a single cash flow. And the next that's being asked is the present value. Okay, so the present value, how much is the value now? That's 1 million. That's what we're going to invest. Okay, and then lastly have type, the comma. Now this type is for annuities. So since we're not dealing with annuities, you can either type 0 there or just ignore. Okay, we'll just ignore that. Okay, whether you put 0 there or 1 there, it doesn't matter because you don't have any annuity. Okay, since 0 naman yung our annuity is 0, then it doesn't matter whether you put here, either you can put a 0 or a 1. But since you don't have any annuity, again, this is immaterial whether you put 0 or 1. So let's just ignore that. Okay, all right, so this is now our function FD, future value. And if you press Control Enter, okay, we have 9646293.09. Okay, the same as before. Okay, so let me pause for a while and ask the class if you got a negative 9646. Okay, so please feedback. You should be getting negative 9646. And let me explain why it's a negative. I just flashed the, yeah, correct, no? Negative, yes, that's correct. But did you get 9646293? So the answer is the same, right? Absolutely, in absolute terms, we got the same answer as using the formula, which just proves that the formula that we used is the same as the FD function. Okay, now let me explain why this is negative. Okay. Okay, how will Excel treat this? So this is our formula, right? Our rate is, this is 12%. Our NPER, this one is 20 years. And then our PV, this one, is 1 million positive. Now, when Excel read this, it will read the positive as an inflow, okay? Money coming in. So it means it will be treated like a loan. You borrowed something, right? So Excel is now using its syntax. Okay, it says that since your present value is positive, which means this is cash in, which means you loaned something. The reason why you got 1 million is that you loaned it. Therefore, at the end of the period and the future value, it gives us a negative answer because it means that it will be a cash out. It means that you're going to pay the loan. Okay, that's why you're getting a negative answer. Okay, let me pause for a while. Okay, again, question, guys. Do you understand now why Excel is giving us a negative answer? The reason being that Excel is very particular about the direction of the cash flow, whether it's money going in or money going out. So here, we made it positive, right? Which means that Excel read this as a loan. So you had the loan, money went in. So after 20 years, it's negative because you have to pay that back. Had I placed a negative here, let's suppose I put a negative here. Okay, negative, enter. Notice what happened was the value here changed, it became positive, right? It became positive because Excel treated this as a cash outflow, which means you invested something and at the end it will be cash inflow. Okay, so let me pause for a while and seek clarification with you if you understood why Excel is giving us a negative answer. So chat please, guys, if yes or no. If you got the answer, if you understood why it's a negative answer, negative 946. Okay, no answer, no feedback, please. My question is, do you understand why Excel is making this a negative? Okay, thank you, Gerard. How about the others? Guys, waiting for the others' responses. Okay, thank you. Okay, good, thank you. All right, thank you so much for your responses. Now, if you feel bothered with this because it gets confusing, and let's suppose we're not really interested to know if it's a loan or an investment, we just want to know the value. So what you can do is just put a negative sign here in front, there, negative, and that will take care of the negative sign. Okay, all right, so it's positive now. So we're not really looking at the fact that this is a loan, which means cash going in, or an investment, cash going out. What we're interested in is the value of 1 million, whether it's a loan or an investment, after 20 years, if the rate is at 12%, and it gives us 9464293. So what I did was just to put the negative sign here. Okay. All right, good. So notice that the formula is PV times 1 plus R raised to the T. This factor here, 1 plus R raised to the T, Okay, this process of getting the future value is called compounding. Okay, compounding. All right, so if the number of years were on the other hand 30 or 40, okay, so let's compute as a practice to get the future value. So this is equal to, let me just put here negative FD. Okay, our rate is same 12%, NPER is 30, PMT ignore because this is not an annuity, this is just a single cash flow, 1 million. Okay, all right, you see the difference, guys? You see the power of compounding. 20 years, 30 years, there's a difference of 10 years. Okay, you just add 10 years and already this was already times 3, almost times 3. How about if it's 40 years? So it's equal to, once again, negative FD. Rate is at 12%, NPER is 40, PMT ignore, PV is 1 million. Okay, so let me pause for a while, allow you to catch up with the formula. Okay, control enter. Okay, 93 million, wow. So you can see the power of compounding. And as we illustrated a while ago, the curve is exponential. Okay, where's that? The curve is exponential. So as you increase the number of years, it will keep on increasing exponentially, very, very steep going up. Okay. All right, let me pause again, guys, and kindly chat, please, if you are able to get up to the 40 years. Chat yes if it's clear so far, or should you have any questions, please feel free to chat them also. Thank you. All right. Actually, we can see that here, diba? Yung 90 years or 40 years, diba? Ito. See here, 40 years, 93 million, diba? Okay. You can see here the compounding. All right. So let's now go to the reverse process. So a while ago, we were computing for the future value. Now, on the other hand, if we're given the future value, and then we would like to compute for the present value, then the formula becomes PV, present value, is equal to future value times 1 plus R raised to the negative T. Okay, so let's just illustrate that. So our formula has become let's see if I can. Okay, a while ago, the future value is equal to, hindi siya stable itong present value times 1 plus R raised to the T, right? Now, we can compute for the future value by transposing this. This, by the way, is called your compound factor. This is called compound factor. And when we compute for the present value, it will become equal to future value divided by 1 plus r raised to t. Okay, so this is 1 over 1 plus r raised to the t. And the 1 over 1 plus r raised to the t is called your discount factor. Okay, and it's the same as, you know, from your algebra. This is just equivalent to, okay, where's my, I'm having difficulty with the interface of my digital pen and Windows. So this is the same as future value times 1 plus r, okay, raised to the negative t. It's the same, okay? It's from your algebra. This is called your compound factor. And this is called your discount factor. Okay, so it's either 1 over 1 plus r raised to the t or 1 plus r raised to the negative t. They're the same. Okay, so let's reverse the situation. Suppose we were given that the future value is 9646293.09, which is this one, right? So you're asked to get the present value given the future value, number of years, and rate. Of course, we expect to get 1 million. We should be getting 1 million. So let's use the formula first. Let me interchange this. Let's use the formula first. So it's equal to, the formula is the future value okay, so this is equal to, we know the future value times 1 plus the rate, okay, plus the rate raised to the negative t. There. And we're supposed to get, as expected, we have to get 1 million because we're just reversing the process. Okay, let me flash again the formula. And again, class, I request your comments. Chat, please, if you were able to get the formula, if you were able to get 1 million as expected. Dapat 1 million yan, guys. It should be 1 million. Otherwise, there's something wrong with your formula. Okay, so I hope everybody got it. Okay, so thank you. Okay, then, or we can use the Excel function. Okay, for the Excel function, we use, wait, baka may question. Okay, thank you. Okay, for the Excel function is equal to, we use PV. So there's a PV function. So a while ago, to get the future value, we used the FD function. Now, to get the present value, it says here, returns the present value of an investment, the total amount that a series of future payments is worth now. Okay, so PV, open parenthesis, the rate is 12%, comma, NPER is 20, number of periods, comma, PMT ignore because this is not an annuity, comma, future value is 9646293, okay, comma, again the type ignore because this is for annuities, okay, and if I press enter, I expect to get 1 million also, but I'm getting negative 1 million because I said that control 1, Kung natin i-currency number lang. Okay. I'm getting a negative answer here because I said that Excel was treating this both as an inflow and a cash flow. Okay, so if I remove, I'll put a negative sign here so that it removes the negative answer. Okay, because we're not interested in whether this is an investment or a loan. We're just interested in the amount. How much is the present value of 9646293, which is their cash flow in 20 years time at 12% interest. And you should be getting also 1 million. Okay. Let me flash the formula for those of you who were not able to follow yet. And then once again, guys, as usual, you know the drill. I'll be asking you if you were able to get it. Pakichat na lang, please. Okay, thank you. I hope you don't mind me asking questions if you're able to get it. Because from my experience, the others are maybe not yet that well adept with Excel. So it's important for us to support, no? And to help those who are having problems with their Excel. Okay, good, good. So I think most of you were able to get it. All right. So no problem with getting the future value or the present value in Excel. They're very easy. They're very straightforward. In fact, the PV and the FD function, you just have to know what the terms are. Okay, for example, the rate, you know that. The NPER is number of periods. The PMT, that's the annuity, and that's what we're going to discuss today. Okay, next. Now, no? So we have the annuity. Okay, what is an annuity? As discussed a while ago, an annuity is a uniform stream of cash flows. You can see here an annuity. Okay, so this is an annuity of 2000. So it begins at year 1, 2000, 2000, 2000, 2000, 2000. The cash flow should be uniform. They should be the same. Okay. On the other hand, this one is also an annuity. Okay, let's, sorry, kindly delete this. Okay, this is also an annuity of 5 cash flow payments of 2000. So there's a difference between the first one, where the cash flow starts at the end of the period, at the end of year 0, at the end of the beginning year. On the other hand, this one starts immediately. Okay, and we have a name for this. For the first case, where the cash flow begins at the end of year 0, at the end of the first period, then this is called your ordinary annuity. Okay, it begins at the end of the first period. This is the first period. Okay, so at the end of the first period or at the beginning of the next period, your cash flow begins. On the other hand, this one is annuity due. Okay, annuity due, and it begins at the beginning of the period. Okay, so you have here some pretty tough formula. No? Okay, so here you can see P. Okay, what we're computing here is the this is the formula to get the P, the annuity. Okay, so P is the payment. That's what we're looking for. And PV here is the present value. R is the rate. And N is the number of periods. So we'll deal with this in a while. On the other hand, the PV, the present value of an annuity, is equal to the annuity multiplied by 1 minus quantity 1 plus R raised to the negative N over R. So the formula is quite more challenging. Okay. All right. So first, let's compute for this one. Okay. we're going to use both the formula and the Excel function. Okay, first we're asked to get the present value of an annuity. So this is the formula for the present value of an annuity. Okay, we're given that the payment, the annuity, is 30,000. So that's your P here. Okay, interest rate is at 10%. That's your R. Number of payments, that's your N. Okay, so 30 years, number of payments. Okay, so we are asked to compute for the present value of an annuity. So we're going to use the Excel function and this formula also. Okay, so let's take a look. Let me go down here. Okay, so let's compute for the present value. Okay, in other words, okay, let's visualize first what we're doing. It's a problem. So we're asked to compute for the present value of an annuity of 30,000. Okay, so I think I do that here. Here. Okay, our annuity is 30,000. So let me just type 30. Okay, 30 for the next how many years? 20 years. So 20 lang. Okay, sorry about that. 30 for the next. Well, okay, why don't we do this? Let's just make this. Sorry about this. Let's just make this 30 years. Okay, let's just make this 30 years. Oops, sorry, not that. Control Z. But this one. Okay, yeah, it's 30 years. Okay, so the drawing, the illustration, it's on this side of the worksheet. All right. So for the next 30 years, you're going to, let's say, receive 30,000 every year for the next 30 years. So the question is, how much is the equivalent of this now? Okay, if I'm going to let's say exchange this 30,000 for the next 30 years with an equivalent value now, how much will that be? Okay, so we're asked to find the present value. Okay, so we can replace this 30,000 of an annuity of 30,000 for the next 30 years with one single value, the present value. So the question is, what's the equivalent present value of an annuity of 30,000 of 30 years? So that's the problem here. Okay, so let's use the formula to compute for the present value of an annuity. Okay. All right. So this is the formula. Okay. The P is your annuity, the payment, times 1 minus 1 plus R raised to the negative n over R. So this can be quite challenging in Excel, but we can do this. Okay, is equal to, what's your P? This is our P, right? Our annuity payment, and then times. Okay, let's multiply it first with this one. Okay, so that's okay. I'll pause share now, and I'll ask you to do that in Excel now, and then we're going to compare. We're going to compare answers. Okay. Pause share. Okay, so kindly do it, please. Let's see if we get the same answer. Okay, were you able to get the answer? Okay, let me resume share. Let me show my answer and let's compare, guys. I'm getting 282,807.43. So kindly chat, please, if you were able to get this present value. 282,807.43. Waiting for your chat, please, if you were able to get it. No one was able to get it? Class? Anyone who was able to get 282,807.43 using this formula? P times 1 minus 1 plus R raised to the negative n divided by R. Sige, let me change my question. Yes or no na lang. Were you able to get this? It's okay, guys, if you were not able to get it. It's okay. No, sige. Thank you, Shalina. How about the rest, guys? So coming from honesty, were you able to get 282,807.43? Yes or no? Okay, sige. Thank you. Thank you. Okay, thank you. Yes. Thank you. Thank you guys for your honesty. Okay, sige. That's very good. Okay, because let's now do it. Okay, sige. Okay. Delete natin, no? All right. So how do we do this? First is your P, right? Our annuity. Okay, others use A here sa ibang books kasi nakakalito nga kung P, present value na, tapos P din yung annuity, PV. So maybe it's best sana ginamit niya A. So annuity multiplied by, so we multiply it by the numerator, di ba? And then divide by denominator. So let's multiply it first with the numerator. So this is 1 minus, and then we have to put this in parentheses, 1 minus, the rate is 10%. Okay, close it, and then raise to the negative n. Our n is number of payments, right? It's negative B33. And then we have to close our numerator. So this is now the whole numerator, open parenthesis, close parenthesis, and then divided by, oops, okay, divided by R. Your R is interest rate, this one, there. Okay, that should be your formula, guys. Okay, flash that. Okay, it's time, guys. Is it okay if I ask for 1 minute, please, extension, just to compare the Excel formula and the formula? Permission, guys, 1 or 2 minutes. Little extension. Okay, thank you. Okay. And then how about chatting, guys, if you were able to get this? The answer should be, a while ago, it should be yung 200 plus, no? 200 plus thousand. Okay, good. Good. So I'm getting here. Oops, what happened here? May nabago ba dito? Dali ha. P 1 minus quantity. Dapat plus to, sorry. This should be plus, no? 1 plus R. Okay. Raised to the negative n over. Okay. Control enter. So 282. Yeah, correct. Okay, thank you. So we should have gotten 282,807.43. Okay, and lastly, guys, just to compare this with Excel, okay, is equal to, so we're looking for the present value, PV. Our rate is 10%, comma, N per is 30, right? Here you have your PMT. Okay, PMT is 30,000. There. Okay, comma. We don't have any future value. We don't have any extra cash flow in the future. So we can just type 0 here or ignore that. And then for the type, okay? So there are 2 types of annuity. It's either annuity ordinary or annuity due. If we're not told what type of annuity it is, it's always annuity ordinary, which is at the beginning of the period. Okay? Sorry, at the end of the period. So that should be 0. Okay, so I can type 0 here or just ignore it. Okay. Anyway, I'll just do that, or I'll just ignore the future value because there's no future value, and then 0 here, which means annuity at the end of the period, which is annuity ordinary. Okay, so if I press Control Enter, then I'm having again a negative sign here. Okay, so I'll just put a negative sign in front, Control Enter. All right. So that's about it. Control 1 is to make it just into a number. Okay, so Excel gave us the same answer as the formula. Okay, so let me just flash that for the benefit of those who are looking at it also. Okay, so what we have done so far, learned how to compute for the present value, future value, using formulas, and also using the Excel function. And then we looked at also an annuity, looking at the present value of an annuity, using the formula and using the function in Excel. Okay, so next meeting, we're going to continue with this. Okay, so we're going to look at the other functionalities in Excel. Okay, and then we're also going to look at amortization. All right. So with that, class, thank you so much for your patience. Unless you have any questions. Okay, if not, I hope you learned something today. Okay, so thank you very much and have a nice day ahead. Stop recording.